But the interesting thing is that the line we have got from the point xi, yi, we got this line, and we have got a second line which is xj, yj. They intersect to a common AB point in the parameter space. Let's say that value is a dash and b dash. So this pair of values is basically indicating that xi, yi and xj, yj, these 2 points are sharing the line which can be defined by a dash and b dash. So this is actually what I have explained in the class. So if you have 50 points on this straight line, you do the same thing. What will happen? In the parameter space, you will have 50 lines which will intersect at a dash and b dash. So that means all those 50 lines, if they are collinear, they will have the line coefficient a dash, b dash. That means that particular line is the line which is sharing all those 50 points. So up to this, do you have any questions? Yes or no? No question? Okay, if you don't have any question, then now I would like to ask you a question. So since we have to define this parameter space, what will be the range of the space in the direction of A and B? Who will answer? What is going to be the range of values for A and B for those two parameter coefficients or weight coefficients? Let me pick one. Fardin, Sadap, Ananto, 208. Will you unmute? Yes. Walaikum assalam. So you can see we have a 2D space, right? The 2D space is defined by the two variables A and B. Since whenever from the point of implementation, we have to define this parameter space. What is going to be the range of values for A and also for B? There is no negative marking, so you can answer intuitively.
So I'm actually a little confused. Sorry.
Okay. So next person, let me pick Nabila Nevaz, rule 216.
Yes, sir.
So what do you think? What is going to be the range? Because for example, whenever, let's say, if you go to the image space, let's say image space is 512 into 512. That means in the x direction, we have 512 pixels. In the y direction, we have 512 pixels. So we know that the range of x is going to be from 0 to 511. And in the y direction is 0 to 511. That we know. But whenever we're moving to the parameter space, what is going to be the range of A and what is going to be the range of B? What do you think? Is it going to be 512, 512 or something smaller or bigger? What do you think?
I think the negative range to the positive range, like of the image space.
Okay, that means you're saying from minus 512 to plus 512, something like that one?
Yes.
Yes. Okay, you have got the answer partially correct. First of all, since the line coefficients, the value of A and B can be, that is, for example, the slope. The slope can be some positive values, can be some negative values, right? Also, the y-intercept can be some positive values, it can be some negative values. So basically what happens, the range of values of A and B are going to be, I mean, in the ideal case, it doesn't have to be like 512 or anything like that. It will be even bigger than that. Since it is bigger, so it is kind of large space and we don't know how to define that large space. So normally the ideal case will be from minus infinity to plus infinity. Okay, for example, if the angle of a line is 90 degree, tan 90 degree, what's the value? What is going to be the slope value? Tan 90, what's the slope value? Nabila?
Sir, it's infinity.
Okay.
I mean, undefined.
Undefined, right? So, but a line can be perpendicular, yes or no? In your image space. So if you have undefined, so that means your parameter space has to be from minus infinity to plus infinity, right? So
Yes,
that is a problem. Yes, that is a problem. So that's why instead of representing the space with xy, what we do, we represent the space from the perspective of, let's say, the polar coordinate system. Okay, for the polar coordinate system, so we represent the, let's say, any position, or let's say any shape, we can represent by angle and distance. Yes or no? Right? So in this case, we have the equation representation from y equals to x plus b to x cos theta plus y sin theta equal to rho. So now if you look at this line, so previously that line was represented by slope and y-intercept. Now the line is represented by an angle of theta with respect to the x-axis, that is the angle, and rho is basically the distance. Okay, it's the distance from the origin to the line. So what is the benefit of having this rho theta representation? The rho theta representation benefit is that if you think from the perspective of the rho, the distance, okay, so what can be the minimum value, or what can be the distance value, maximum distance value possible? What do you think? Let me pick someone else now. Samim Yasir, can you unmute? Okay, probably he's not in the class. Okay, then the next person, Tanzil, rule 246. Can you unmute? Okay, so what do you think? So in your image, if you have a line, what is the maximum distance that is possible in the image space? What do you think?
I think
So the rho means the distance from the origin to the line. So the maximum, how much distance is possible within the image?
I think the amount of pixels that are like
In which direction? The x direction, y direction, or diagonal direction?
doesn't it like depend on the orientation of the line?
Yes, that's why I'm asking you.
So what was the question again?
I'm asking that the distance value, what's the maximum distance value possible?
That is in the diagonal direction, I think.
In the diagonal direction, right?
Yes, sir.
Okay, so basically if you see in this way, oh sorry, can you see my screen?
No, sir.
You can't see my screen?
No.
How about others? Can you see my screen?
Yes, sir.
Okay. So, okay, then probably you have some problem with it. Let's say this is your image. Okay, this is your image size of, let's say 5 to. So let's say if you have a line, if I just draw a line over here, just over here, a small line. So what is going to be the distance value? So you see there is a diagonal value of d. Okay. There's a diagonal value of d. So you will have this distance, the value of rho will be what? Some distance value of plus, right? Yes or no? Similarly, from the point of the value of theta, what's the angle possible? What do you think?
So I think 45 degrees.
45 degrees.
No, it can start with 0 degree. Yes or no? Let's say if you have a line that is exactly oriented like this, what's going to be the angle of the line with respect to x? It will be 0 degree. Yes or no? Right? Are you with me? Do you get my point? So what does theta represent? What does theta represent? So theta represents the angle that the line has produced. Basically what will happen, so basically if you draw a straight line like this, then whatever the angle has produced with respect to the x-axis, that is basically what we have defined, theta. But normally I say that the angle that the line has produced, because basically this angle and the other way around is just 90 degree apart actually. So if you think like this, so you can see that the value of theta can range from 0 to, normally we can say 0 to 180 degree. And if it ranges from 0 to 180 degree, basically what we can say, the same angle we can represent from minus 90 degree to plus 90 degree. Yes or no? Still we have this 180 degree range, right? Is it understood? Since the angle has been represented from minus 90 degree to plus 90 degree, again from the point of the distance, the value of d, we know that for this particular example, let's say if the diagonal distance, the maximum value is d, then the rho value can range from plus to minus of some d value, where d represents the diagonal distance, the image that you have in hand. Is it clear? Up to this. Any questions? I'm asking everyone. Do you have any further questions on this one?
Sir, I didn't get the like minus 90 to plus 90.
Okay. I mean, let's simplify it like this. Let me draw a white. Okay. Can you see my screen?
Yes, sir.
Okay. Think in this way. So let's say in this case the angles are ranging from 0 to 360 degree, right? Yes or no? So in your image space, let's say if you draw an angle like this, what is the angle? Think like this. Let's say this is x, and let's say this is y. So this particular, let's say this particular line, what is the angle that you have got? You have got the angle of some value of theta, right?
Yes, sir.
Okay, you don't have to unmute, okay? Just you have to respond with all my questions one after another. So you can see that if you have it, so if I have an edge like this, okay, let's say in image space, let's say this is your image. So what angle do you have here? What do you think? The second line that I've drawn, what angle do you have here? So this is the same line. If you think from the point of orientation, is the same line like this one, right? And then you will have some angle theta, which is basically same as this particular theta. Yes or no? Anjil, are you with me?
Sir, how are both of these angles equal to theta?
I mean, which one? The theta dash? I'm talking about theta dash now.
Yeah. So now
So this is, I mean, from the geometry that we know that this angle and that angle will be same. Yes or no?
Yes, sir.
Okay. So now you can see that all the edges that is possible within the image. Let's say the one that I've drawn in the rectangle. So everyone will be ranging from which angle? From some, sorry, it should be minus. Sorry, everything got lost probably. Let me try it again. So we had one line like this, and let me draw another line. Here, the green line, we have another line like this. So this line had the same angle as this one. So basically what do we see from here? All the angles are now, you can say that they are going to range from minus 90 degree to plus 90 degree. Yes or no, Tanjil?
Yes, sir.
Okay, so you see that whatever the image, I mean, in your image, whatever the lines you have, the angle can be represented within the range of from minus 90 to plus 90, right?
Yes.
Okay, so basically some of the implementation ranges from 0 to 180. Okay, and sometimes you'll see the implementation will range from minus to plus 90 degree. Okay.
Yes, sir.
Okay, so now you can see that Whenever we have the representation of the line as x cos theta, like we have seen before, x cos theta plus y of sine theta equal to rho. Now we know that the value of theta, okay, the value of theta can range from plus minus 90, and the value of the distance rho can range from where? From plus to minus of some diagonal value. That means in your image, whatever the diagonal distance is possible in your image. So let's say this distance is some d. So that means the value of theta is now ranging within a finite range. Can I say like this, Sanjil?
Yes, sir.
So in our previous representation of the line, we had y equals to ax plus b. But the problem with this, parametric representation is that the value of a and the value of b can have infinitely big range, right? From, let's say, from plus infinity to minus infinity. But instead of going to this particular mathematical equation, the same line, if we have this polar representation, then we can see that the parameters that we are looking for, let's say theta and rho, they have a finite range. Since they have a finite range, that's why the parameter representation is better whenever we use the rho theta space. Is it clear?
Yes, sir.
Okay. So this is basically what we have done. Okay, that means from the parametric representation of y equal to x plus b, we have moved to the polar representation of x plus cos theta, ax cos theta plus y sin theta equal to rho. Okay. So now in the implementation that I have given you, you will see that they have used this polar coordinate representation of angle and distance. This is actually what they have used. Okay. So this is the theory that we have talked in the previous class. And then again, what we'll do in the polar coordinate system, if you see that if you do the voting, the voter are no longer straight line. You see they will appear as some periodic curves. Okay, why they will appear as periodic curves? Because in your equation, okay, you see in your equation you have this cos theta sin theta. That's why whenever you are doing the voting in the parameter space, you will see there will be some periodic curves. Okay, but even though there are some different kind of periodic curves, the periodic curves will intersect to some common points. So again, the main concept is same. We simply look for intersection points, and once we have the intersection points, if we have, let's say, 50 points on this line, so all this periodic curve will intersect to a common point. And if you look at count the vote, or if you keep on voting, the point with the certain threshold vote we have, if you set a threshold value, that is the line you are looking for. Okay. So now let's move to our Python code. Okay, so
sir.
this, yes.
Sir, I'm ID 234. My mic was disturbing, that's why I couldn't respond.
Okay. Okay, next time you'll be responding with me this time now. Now it's okay, right? Yes?
Yes.
Okay. So basically this is what we have. This is the code that I have given you. So first of all, what you do, you simply run all these codes, okay? Then there's one thing we have done. If you look at this, let me look at the image, okay? Let's display the image. Let me display the image after I resize it. Okay, now what did we do here? So I loaded the images. Okay, I have already given you the shareable Google code. Okay, not Google code, I mean the shareable code identifier actually. Or I have also given the code in the classroom. Okay, you can simply load whichever image you want, and you can run the code. So basically what we have done, we have computed the edges. Now we know that in case of edges, we will have thick edges, because whenever you use the Sobel operator, we get thick edges. So since I want to have single pixel thick edges, so I have used the Canny edge detection algorithm. So I haven't taught you the Canny edge detection algorithm, just it's a edge detector will give single pixel thick edges. Okay, so if you just simply run this code, so basically you will have these edge responses, and all these edge responses are single pixel thick. Now, if I look at this particular image, so think from the point of an autonomous driving car, let's say Tesla car or any kind of autonomous vehicle. So you want to detect the lanes, right? If you want to detect the lanes, so what you want to do? You want to detect the straight lines. So in this case, you will want to detect the straight lines, and you can see that for the lanes, we have got the straight lines. We'll also see some straight lines which will come from the border fence. You can see on the side of the road, and also you will see if you look at the horizon. Okay, the horizon also kind of gives you another edge. So whatever the edge you have got, our first thing is that you want to get straight lines. Okay, so from that objective we will run the Hopf transform. So I have used the built-in code from the CV libraries, OpenCV library actually, Hopf lines if you just call it. Okay, and then you see the angles, theta angles. So you have to define the resolution. Okay, so basically we have the angle ranging from -90 to +90. So I have taken the degrees to be 1 degree apart. So that's why I have divided by 180. Okay. Another thing is that here you can see that the threshold value I want. That means if you want to detect a line, at least how many pixels should be on the line? What did I define here? মাইকটা আনমিউট করতে বললাম কাকে জানি আনমিউট রাখতে বললাম
So 175.
yes see. Okay, so how many votes do you expect to have?
So বুঝিনি what?
From the point of the Hopf transform, we have mentioned that you will have some intersection whenever you are doing the voting. So at the intersection point, let's say if there are 50 pixels that are collinear, that means they all belong to the same line, then how many votes will happen at the point of intersection if 50 points are collinear? It's going to be 150, right? Sorry, it's going to be 50. For 50 pixels, the vote will accumulate to what? 50, yes or no?
Yes, sir.
Okay, so in this case, instead of 50, I want to have, considerably significant lines. That's why I have defined 175. You can change this particular threshold value to see what is going to be the value of the number of accumulation, minimum accumulation that you want. Okay, so we are running it. So once you have run it, so all these, the parameters will be stored in this particular variable. And then if you want to draw all those lines, all the lines that he has at least 175 pixels, if you run it, what do you see? So have you detected the straight lines? Yes or no?
Sir, what the horizon one?
Okay, so why do you think the horizontal one did not come up here? What might be the reason? What do you think?
Also the right side border is not detected.
Let's say if I reduce that one, so now I want to have those lines which has at least 75 contributions, right? Let me run it again. What happened now?
Oh my god.
Everything is
There are too many pixels. Sorry, there are too many lines which has at least how many contributions?
75.
75. Okay, let's try to change it to 100. Okay, if I increase this threshold value, what do you think what will happen?
The line
number
will
of decrease, because what I'm asking for,
only the straight lines which for the lines, the borders, and the horizon.
Okay, so this code you might want to make it more interactive. Okay, because I have to run it in several places. Okay, still it is too high, right? Okay, I think we have a threshold value of 350. Let's see what happens with 350.
লাঞ্চের সময় তো দেখলাম স্যার গাড়িতে সেই যায় রাস্তায় সেই যায়
Okay, what happened? Is it too much? Threshold value I have set. And now let's see. Is it running okay? Let's say if we increase it too much, if we don't have any lines, then that's going to be a problem. Let's say 275. Reduced, right? Yes or no? Did it decrease? Let me try it again. No, it didn't decrease yet. Okay, let's make it 200. Let me see. The lines have reduced, right? And if you want to increase even more, what will happen? Let's say 250. Or 250, maybe not many. Because maybe it is too high. Let's say 225. Oops. এর আগে থ্রেশহোল্ড কত দিয়েছিলাম? 205 দিয়েছিলাম। How will it work? Do we have to run from the start? Probably no.
Probably, sorry.
Just one cell before, because the edges values are storing from the previous cell.
But we have, because the edges values, we don't want to change it because all the detected edges are same as before, like we have done over here. And then this code will simply take the edge pixels, okay? That means whatever we have detected from canny edges, it will apply the Hopf transform and it will give you the parameters for the detected lines, which will have at least this number of contributions, okay? That's the thing. That's yes.
After we are putting edges on the image.
Okay. Now I think we see now. See how many edges have we got?
One.
One. Okay. So each time I change, I have to run everything. Let me check now. If I say 175. Okay. Let me run all these things before. Run it. So with 175, this is the number of edges we have got. Okay. So let me even reduce it even lower. Let's say 150. Let me so that the number of edges are gradually increasing, yes or no?
Yes, sir.
I mean the detector lines actually. So okay, let's try to reduce it even further. 100. Now it's too many, right? Now it's too many. So you can see that what we have to do each time we are doing something, we have to tune these parameters until we are happy with the outputs. Okay. Now I have said what value did I set?
125.
I set to 125. Now at this point, do we get the horizontal line?
For the horizon, yes.
Yes, almost. You see, we have got the horizontal line in this direction, right? Okay, because if we look at the edge pixel output, you see there are few pixels which are almost collinear that defines the horizontal line, right? And you see there was a tree line, so the tree lines, they are not collinear. So you see the contribution, if you want to get a horizontal line, maybe the vote should be around 120 or something like that one. If it is too high, what will happen? Even the horizontal line, we are going to miss it, right?
Yes, sir.
Yes, this is what's happening. This is the thing actually. But let's see that, for example, if we get the vote, expected vote is 150, then this is the edges that we have got. Even though one of the edges came from the side fetch, right? So maybe if you want to increase it, maybe this will go, but still with this number of edges, for a, let's say, autonomous driving vehicle, somehow we can detect the lanes because the car will be at the middle. And so if you take the two side straight lines, the closest two straight lines at the side, then you'll be able to navigate the car in the middle of the road, right? Yes or no?
Yes, sir.
Okay. So this is going to be your task actually today. So you see all this accumulation has been done where? It has been done basically, you see, in the built-in code by Hopf transform, Hopf lines. Okay. So what I will ask you to do, okay, I ask you to implement this Hopf transform by yourself. Okay. And then you have to display the Hopf space. If you display the Hopf space, what kind of output do you expect to see? What do you think? What kind of output do you expect to see? Let's say if I look at this particular example, you see, in this particular example, you will see that after doing Hopf transform, we will detect significant horizontal edges that will be aligned in these directions. And once we do this accumulation, the accumulation output, or the Hopf transform output will be something like this. And if you go for the highest pixels, contributing line or edge pixels, what will happen? You will be able to draw the straight lines according to the threshold values. So your objective now is to produce this accumulation space where you have to implement the Hopf transform yourself, okay? And then you will be able to display the voting space or the accumulation space. Is it clear? Is it clear?
Yes, sir.
So basically what I have done here, I have used the built-in library to do the voting, to do the thresholding, and give us the set of coefficients that fulfills at least 150 of vote. So this Hopf transform algorithm, you have to implement yourself. At the same time, you have to display the Hopf space. And once you detect, you implement the Hopf space, what next you have to do? You have to apply a thresholding on the parameter space. That means from the Hopf space, you'll get the list of parameters which satisfy or which exceeds this particular threshold value, whatever threshold value you can set. And then for all those set of parameters, you have to draw the line on the top of the image that you can see here. So this one is done with this code. You can take help from this code, or you can draw it by yourself. It's up to you. So is today's task clear what you have to do? That means you have to implement the Hopf transform, that particular algorithm, by yourself for straight lines. Once you do this, then there is a home assignment too. This home assignment, you have to apply the Hopf transform algorithm for circle detection. Okay. Sorry. Okay. You have to do it for circle detection. So in the same case, what you have to do, you have to detect the edges from the image. That's why I have given you a particular image that you can see. If you look at this particular image, so what do we see? We see a lot of circles, right? You see a lot of circles. So from this image, you have to detect circles. So first what you can do, you can try to detect circles of a fixed radius. Once you can do it, you can extend it to detecting circles of any radius. So for that, we first need to detect the edges, apply the Hopf transform for circle detection, and similarly, you have to display the accumulation space. Okay, accumulation space, and similarly draw the circles, the detected circles on the top of the input image. Is it clear? This is a home assignment. This is what you have to do. I will give you some time, let's say 10 days. And within the 10 days, you have to implement the Hopf transform. But today's lab, you have to just rewrite the code. That means you have to implement the Hopf transform for detecting lines by yourself. Any questions? Questions? No? Okay. Then I will leave it up to you to start your implementation. And whatever you have done your implementation, I have given you up to 10 minutes past 5 o'clock to submit your today's tasks, and then I will give you another 1 week or maybe 10 days to submit the final report. So Dihan, can you hear me?
I can hear you.
Okay. So I believe you can take the attendance.
Sir, I have taken the screenshot of the participation list. Will that be enough?
Okay. So in the case, you have to manually update the attendance sheet. Okay.
I would do that.
Okay. So I will leave it to you. So I have a meeting to attend in Dhaka. So I will leave today's lab session under the control of Mr. Dihan. So he will conduct it from here. But before I leave, I want to hear any questions if you have in your mind. Sufyan Shahi, can you unmute your microphone?
Sir.
So I can see that you have already submitted.
Sir, I was just testing some codes. I have not actually submitted the whole thing.
Okay.
The task 3 is not done yet. actually.
Okay, but I can see that you just submitted everything. Yes or no? Even the
So
hops, I can see you have also you have done and implemented the display of the Hopf transform. You have done it. You have done it by yourself, or Gemini has done it for you? Which one?
sir, I took some help from the AI.
Some help or almost all help? Which one?
But the mostly it was done by AI.
So that's what you think. So if you do like this, you won't know actually what's happening with each of the lines. But yes or no?
Yes, sir.
Okay, so try to do it by yourself. Okay, you still have time till 5 o'clock. Okay, so you can do it by yourself. Okay.
Yes, sir.
Okay, so I will leave it to you. Okay, so please complete. It's a easy. I mean, set of lines that you have to write. Okay, the equations are all there. You just have to write 2 for loops, and you can do voting in the accumulation space. So you can see the accumulation space in this case. We know that it is going to range from -90 to +90. So you can either pick the degree, and then you do it for all other row values from -d to +d. Put the values in the equation, okay, and then you do the voting. And the voting is simply done by incrementing the value of the accumulation by 1 that falls along the equation that I've shown you. Okay, that means the rho theta parameter space. If you do the voting in that one, you can easily see the output. Okay, so that's all from my side. Okay, keep on coding. So I will leave Dihan listening.
Yes, sir, I'm listening.
Okay, so I believe you will be able to answer questions if students have any.
Hopefully.
Okay, thank you.
Assalamu alaikum, sir.
I'm going to make you co-host, okay?
Okay, sir.